Okay, there we go. All right, so guys, this is what we're doing this week. So let's see. Number one, guys, I always hope this is the case. I hope everybody's doing well. Nobody in your family is sick or ill or anything like that. But what we're going to do today is we're going to cover section 5.3. So guys, just like we're doing one section a day, right? I'm hoping that the pace of the class, I know the problems take time to do. That's why the pace of the class is one section a day, because the problems do take a considerable amount of time to do. So the notes for 5.3 are right here. The homework for 5.3, guys, it should be open now. It's open up. I always set it up to where it's open at 2 o'clock. And it's due by next Monday. On Wednesday, guys, we're going to go over 5.4. The notes are right there. That homework will be open on Wednesday at 2 o'clock. It's due the following Wednesday, which is, this is not the right date. Everything is on Alex, my friend. So right here, this should say 10/6. So let's fix that. Boom. And that's the date that I actually have on there, guys. I just put the wrong date here. And let's see. So, guys, I am going to be uploading the videos to the playlist on YouTube. So, if you want to look for it, it's right there. Okay, and then I went ahead and I set up the review for us. Okay, the review for our first test. So, our first test, guys, is going to cover chapters 4 and 5. Okay, 4 and 5. And so, I set up a review. The review should be open today at 2 o'clock. So, it should be open already. The review is due by 2 o'clock. Let's see, I actually just changed this, so I'll fix this in a little bit, but I think I made it due later than this day. Let's see, I think I made it due on the 18th, but I'll double check with you guys. So anyway, on Wednesday, October the 6th, which is not this coming Wednesday, but the following Wednesday, all that day, all we're gonna do, answer questions from the review, okay? Now, that doesn't mean that you need to wait until Wednesday to start doing the review. You definitely don't want to do that, right? So the review is already open. So remember, we've already covered chapter 4. So my recommendation would be, whenever you knock out the homework for 5.3, if you get 5.3, if you start knocking out that homework, if you start doing some of that homework for 5.3, the sooner you're able to knock it out, the better. But what I would do is every day, I would start doing a little bit of the review. Try to do 2 or 3 problems a day, okay? Maybe 4 or 5 problems a day, whatever it is, right? But try to do as many as you can. And guys, if you get to problem number, I'm going to make this up. You doing the review, problem number 1, easy breezy, cover girl. Problem number 2, same thing. You get to problem number 3, you don't know how to do it, skip it. Go on to number 4, right? Do all the ones you know how to do first. Nobody tells you got to do 1, then 2, then 3, then 4. You can go any order you want, okay? So the review, guys, has 28 questions. When we get ready to take the test, the test is going to have, again, it covers 4 and 5. I want you to look right here. The test has 14 questions. Where do those 14 questions come from? Directly from the review, right? They're the same problems, right? Okay, so what does that mean? You know, when you're doing a problem in Alex and it tells you try another, okay, and you try another, and the problem might change a little bit. The numbers might be a little different, or instead of a sine, it's a cosine, but the problem in itself is pretty much the same. That's exactly how the test is going to look, right? It's going to look very much the same. So if your problem was, find the 6 trig functions if sine of theta is equal to this and in theta is in quadrant 3, and then it tells you that was your problem that you had in the review, and now it's telling you find the 6 trig functions if cosine theta is equal to something and theta is in quadrant 2. In essence, it's the same type of problem, right? You may be in a different quadrant, but you're going to draw the picture exactly the same way, right? You're going to do this. You're going to apply the same principles. So that's what I mean by they're taken directly from the review. Okay, it's not going to be. It shouldn't be drastically different. Okay. The test, guys, I'm going to open it on Tuesday the 12th, and you got to make sure you get it done by Monday the 18th. Okay, so you got some time to get it done. You can use any calculator you have. So some of you do have graphing calculators. You've seen me do the Graphing Calc app or the Calculate 84. You can definitely use those, okay? The other thing, guys, what I have here are fundamental trig identities. So let me pull that up for you guys. I'm going to stop sharing this so I can share that piece over here so whoever decides to watch this later can see it. And boom, there we go. Okay. So this is like a formula sheet, guys, that I have here for you guys. And all I did is copy and paste stuff. But So some of these identities, guys, I mean, you obviously have the formula sheet here, right? You have the identity sheet right here. My point, though, is even though you have it, there should be some of these things that you should say, I don't necessarily need to look at the formula sheet to know some of these. What I mean by that is like the reciprocal identities, those you should know them, right? And if you don't know them, then you want to get to know them better, okay? So you should know that the cosecant of an angle is 1 divided by the sine of the angle, or the secant of an angle is 1 divided by the cosine, or the cotangent is 1 divided by the tangent. You should know those identities should be something that you're familiar with, okay? You shouldn't have to say, hold on, what's secant again? And I got to go back and look at it every single time. Think about when you were in junior high. I'm pretty sure this is how everybody's junior high math experience went. They gave you a table that said 1 through 12 and 1 through 12. And you started filling out a multiplication table, right? Everybody probably did this some point in junior high, maybe even maybe it was even elementary school, right? Maybe it was 4th grade, 5th grade, whatever it happened to be. And for some people, 7 times 8 was always a tricky one. So you would go and you look at the table, oh, it's 56, right? And you had to do that a couple of times. But eventually, you knew that 7 times 8 was 56 because you looked at the table often enough. That's kind of how you want to think of this here, right? So if you don't know it, that's okay. But you want to get to know it so that you don't have to go back and reference it every single time, right? Okay. So I would definitely say reciprocal identities, quotient identities. And in terms of Pythagorean identities, I would definitely say the first one is one you definitely want to know. Okay, you just really want to know this. It's just going to make it that much easier. Okay, now obviously I don't expect you to memorize the sum and difference formulas, right? The reason why I'm talking about knowing these, if you have to go back and figure out, hold on, what is cosecant? Oh, that's 1%. If you have to do that so often, it's just going to take you a lot longer to get through the problems. Sum and difference identities, you don't have to memorize them, just know how to use them. If you see the formula here, copy it down correctly and you can apply it, right? Same thing for double angle, half angle. And again, we haven't talked about all of these yet, but we'll talk about them as we go through this week and beginning of next week. And then one of the things that we did, guys, we did do the difference of squares before. So I just went ahead and put that in there. And perfect square trinomials, so like if you have a squared plus 2ab plus b squared. What I mean by that is if you have an expression, I'm just going to make this up. If it's sine plus cosine, the whole thing is being squared. You can use this sort of formula and apply it where a is the sine and b is the cosine, and then you can just kind of fill in the blank. Or you can use like the full method Thomas was talking about earlier today. When I had office hours, I just say, when I learned how to multiply this stuff out, we use the full method. Use the full method, right? These are just some formulas that'll help you so that you don't necessarily have to go through the whole process every single time, but you definitely can.
I know it's squared, so that's why it's squared, but can those be scaled up with like cubed and?
Yeah, there are different formulas, but yes, you can apply it to basically any power, the third, the fourth, the fifth.
So long as the numbers are.
Yeah, and the numbers are going to be, it won't, the formula will be different, right? But there's a formula for each of those there too. Yeah. And then, guys, the other thing I put in here, remember we filled in this little table the other day? I went ahead and again, all I did is copy and paste it, right? And this way, again, when I'm doing a problem, at least I have something to reference to. I may not necessarily I hope I don't need every single one of those values, right? I really don't want to need every single one of those values, but at least I know that I'll at least have them if I need to reference to them, right? Okay, so anywho, you'll definitely have access to this formula sheet as you guys are taking your test, right? So, you definitely want to, and if you don't want to print it out, that's fine, but keep it on a file somewhere on your laptop or on your iPad or whatever it happens to be so that you can go back and use it as you need to, okay? And if you want to print it out, guys, print it out, I don't know if the printer here works, but, the library definitely has one. No, so what I'm going to do, though, good question, is let me stop sharing this. Let me come back and share the screen again one more time, because I'm glad you did ask that. Okay, so let's see. What day did I tell you we're going to go on the review? Okay, Wednesday the 6th, right? That day, I'm going to take the day to review. Now, the following Monday, which should be, what date? The 11th, that day, I'm going to do one section, Okay, I'm going to teach something new that day, 6.1. I haven't actually looked at 6.1 yet, but I'm guessing it's going to be like every other day, right? You finish a little bit early. That day on the 11th, if you still have questions from the review, you'll be able to ask me that day. On the 13th, we're not going to have class. What we're going to do that day, I'm giving you that day, is if you wanted to take your test on that day during class time, you could. You know what I mean? You're going to take it at home, but we won't actually meet on the 13th. It'll be on Alex. And it'll just be like the way you do the quizzes or the homeworks and all that kind of good stuff. No, it won't be a lockdown browser for it. It won't be a lockdown browser. The issue with the lockdown browser then is then you can't access like the formula sheet. You'd have to go print it out. You know what I mean? And I want you to be able to use the formula sheet. Yes, sir.
Are we getting any questions where it's going to have to, like the ones in the room, there's a tanky, like how you solve them? The ones where you have to show the exact identity and follow the 2 steps?
Yeah, I don't know yet. I haven't. So I made the review. I haven't yet made the test. The 14 questions from review, but I will try my best to avoid as many of those kind of finicky problems as I can.
Because sometimes, because I went to the CLE problem, and like they don't even follow the steps. Like, they get to the right answer, it's like they use different orders.
Yeah. So one of the things we'll make sure is on that day that we're going to review any of those problems that we have in the review. We'll remember, just like the way we did that one day, we'll see what's the order that they want this in so that we can kind of mimic what they're asking us to do, right? But again, I'm going to try my best to avoid putting something that's going to be like so finicky that, you know, we can't figure it out. We'll be able to figure stuff out. All right, so anywho, guys, let me stop sharing this and let me pull up the notes that we need for today. Here we go. Okay, so let's see. Let's go ahead and see if we can go through some of this here today. So, guys, we have 5.3. I want to make sure I'm still sharing this. Yes, okay, we're good. And so 5.3 is double angle power reducing half angle formulas. Okay, so let's see if we can make some sense out of this stuff here. Okay, so what we have here, guys, at the beginning, what we have here at the beginning is they are deriving the double angle formulas by using the sine of a sum, the cosine of a sum, and the tangent of a sum formulas, okay? So I'm not gonna go through the how did they get there and do the whole derivation of it, but what we need to know is here are my double angle formulas, okay? So our double angle formulas, the sine of 2 theta is gonna be equal to 2 sine theta cosine theta. The tangent of 2 theta is gonna be 2 tangent theta over 1 minus tangent squared. And then cosine 2 theta actually has 3 different formulas. So one of them is cosine squared minus sine squared. One of them is 1 minus 2 sine squared. And one of them is 2 cosine squared minus 1. Okay. So let's take a look and see if we can't figure out how to do some of these problems. Okay, so look at the problem here. It says, given that the sine of theta is 5/3 and the tangent of theta is negative, we want to find the sine of 2 theta. Okay, so guys, remember how we define the sine? We call it the opposite over the hypotenuse. And in terms of using like the circle, and we have like the x value and the y value and the radius, it's y over r. Perfect. Good. Okay, so look what it's telling me. First question I want to ask you, is the sine of my angle positive or negative? It's positive, okay. What is negative though? The tangent of the angle is negative, right? Less than 0 means the tangent of my angle is negative. Okay, so when we define the tangent of our angle using x's and y's and all that kind of stuff, do you remember what it is? Anybody remember what the tangent is? It's y over x, right? Okay, so take a look at this thing here. Yes, sir. No, not equal to r, it's equal to y over x, right? So now take a look here though. If the tangent of my angle is negative, and we know that the sine of my angle is positive, that's telling me that the y value here, the y value, guys, is going to be positive, which tells me that the x value has to be negative. The only way I'm going to get my tangent to be negative is if one of those was the y or the x would be negative. We know that the y is positive because we knew that the sine of our angle was positive. So the question I want to ask you, what quadrant would we be in if the y value was positive but the x value was negative? Second quadrant. Good. Very good. So look, we're going to draw our picture. Here's our angle. Here's theta. Okay. Now, remember how we defined the sine. The sine is the y over the r, or the opposite of the hypotenuse. So this side here is 5. This side there is 13. We need to find the x value. Everybody agree we're just going to use the Pythagorean theorem here? Okay. X squared plus, what's going to be squared next? 5 squared equals 13 squared, right? Okay, so we have x squared. 5 squared is 25. 13 squared? 169, very good. Minus 25 minus 25. X squared is 144. So remember what we got to do now. We got to take the square root of 144. What's the square root of 144? 12. My question to you guys, am I going to use positive 12 or negative 12? Very good. Boom. So we got that part. Now we have our negative 12. Okay. All right. Remember what it is we're trying to find. We are looking for the sine of 2 theta. Okay. So guys, the first thing I'm going to do right here is I'm going to highlight my sine of 2 theta formula. Sine of 2 theta is 2 times the sine of theta and the cosine of theta. So what I'm going to do is I'm going to come back over here and I'm going to say sine of 2 theta is 2 sine of theta cosine of theta. I'm just writing down the formula, okay? Now the reason why I want to do that is, don't we already know what the sine of theta is? It's 5 over 13. So I'm going to come back over here. I'm going to say, look, this is 2 times 5 over 13 times, I don't know what the cosine of theta is, but I bet you we could find it. What's the cosine of theta going to be? Okay, which is this, in our case, is going to be what? Negative 12 over 13, right? It's the adjacent over the hypotenuse. We'll come back over here. We're going to say this is a negative 12 over 13. Okay. So let's start multiplying. What's 2 times 5? 10. 10 times 12? Negative 120. Okay. And what's 13 times 13? 169. And here is our sine of 2 theta. What do you think? Did it make sense on how we were able to do it? Jennifer, am I doing okay? Did I lose you? Are you sure we're good? Okay, just checking. Javier, we're okay? Yeah, we're good? Thumbs up all the way? Right. So guys, to me, and I'm just gonna tell you this, guys, this is just like from my personal experience, drawing my triangle is gonna be the most helpful thing I can do. I think it's gonna be really, really helpful. If I can draw my triangle, I think it's just gonna help me out so much. Okay, so look, let's take a look at number 2. I'm going to do number 2 the same way. Look, it says, given that the tangent of theta is a negative 5/4 and theta is in quadrant 4, let's find the cosine of 2 theta. Okay, so the first thing I'm going to do, y'all, I'm going to draw my picture. Okay. So here's my theta, here's my right angle, right? Okay, and the tangent is negative 5 over 4. So everybody agree this is negative 5. That's positive 4. And we still need to find the radius. So we got to find our distance from here to here. Okay, so let's go ahead and do it. So we're going to say 4 squared plus negative 5 squared equals r squared. What's 4 squared anyway? 16 plus 25 equals r squared. 16 and 25 is 41. Okay. And then the radius here, guys, is just going to be square root of 41, right? Okay. So that we needed to do. Now, what am I trying to find? Oh, we're trying to find the cosine of 2 theta. All right. So guys, for the cosine of 2 theta, there's actually 3 different formulas we can use. And one of them is cosine squared minus sine squared. One of them is 1 minus 2 sine squared. And one of them is 2 cosine squared minus 1. Which one do we use? It's not going to make really any difference. We're all going to end up with the same answer, okay? So just for the hell of it, I'm going to go ahead and use the first one. I'm going to use cosine squared theta minus sine squared theta, but we could really use any one we wanted. So we're going to say our formula tells us this is going to be cosine squared theta minus sine squared theta. Okay, so the first thing I want to figure out is, do I know what the cosine of theta would be? If here's my angle theta, what would the cosine be? Very good, 4 over the square root of 41. So right here, guys, we're going to write 4 over the square root of 41, but it's being what? Squared. Okay. The sine of theta is going to be what now? Negative. Very good. Negative 5 over the square root of 41. All that is still being squared, right? Okay. So let's go ahead and square these things. 4 squared is? The square and the square root will cancel each other out. That's just a 41 minus, what's negative 5 when you square it? 25, good. The square and the square root will cancel each other out. That's 41. And anybody know what 16 minus 25? Positive or negative? And you are done, my friend. Stick a fork in you, you're done.
Why didn't you
Okay, yeah, because yes, you're right. Why didn't we get rid of the square roots in the bottom? In essence, we did. Remember, we were squaring them though, right? I know, but you're saying, why didn't I multiply the top and the bottom by the square root of 41? There was no need to, because they were being what? Squared. So they were going to cancel each other out anyway, right? So we could do that, but we'd be making more work for ourselves, because it wasn't our final answer yet. If our final answer would have had a square root, then I would start worrying about that. But remember, if you got a square root and you're squaring it, those things are going to cancel each other out, aren't they? Good question, good question. And good response, Thomas. We weren't at our final answer yet. All righty. So let's take a look at this next one here, guys. We're going to do the same thing that we've been doing so far. What's the first thing we've been doing? Anybody know? Drawing the triangle, right? Okay. So let's take a look here. It says the cosine of my angle is a negative square root of 5 over 5, but it tells me that the sine is positive. What quadrant would I be in if my cosine was negative, but my sine was positive? Quadrant 2, right? Good. Let's go ahead and do this. So here's our quadrant 2. Here's my theta. Here's my 90-degree angle. Remember, the cosine is the adjacent over the hypotenuse. That's telling me that this side here is the negative square root of 5, and that side there is 5. We still got to find the opposite side. Okie dokie. So remember, this is my y, right? So we're going to say y squared plus the negative square root of 5 squared equal to 5 squared. Remember, those are going to cancel each other out. That's just going to be a 5. 5 squared is 25. We're going to subtract 5 on both sides. So we're going to get y squared is 20. So now we got to take the square root of 20. Now guys, let me ask you a question. Can we break down the square root of 20 at all? Yeah. When you break down the square root of 20, what do you end up with? Anybody know? 2 square roots of 5, right? So guys, just on a little side note, if you're wondering, how did we do that? Remember what square root of 20 is? We're looking for pairs. This is 2 and 10. This is 2 and 5. What do we have a pair of? 2. That's the one that comes outside. The one that we don't have a pair of is 5. You could have used, instead of 2 and 10, you could have used 4 and 5, and you break up the 4 into 2 and 2, right? So how do you break them up? It's really up to you. Thomas? Okay, the reason why the negative cancels, remember what we really have. We have the negative square root of 5 times another negative square root of 5, right? Because it's being squared. So first off, the negative times the negative are going to be positive, right? And that's going to be the square root of 25, which is just 5, right? Because you're multiplying the numbers on the inside. So the negative and the negative, because you're squaring it, a negative times a negative is a positive. And then when you multiply the numbers inside, 5 and 5 is 25, but you still got that square root. So the square root of 25 is just 5. Okay, so now we have this part here. So now we know that this piece over here, y'all, I'm just going to erase this. I'm going to put this is 2 square roots of 5. Okay, so look, we're going to find each of these pieces. So let's go like this. Sine of 2 theta. Now, guys, one thing I want to mention to y'all. When you're sitting at home this afternoon or later tonight or tomorrow morning or Friday, whenever it is, when you're doing your homework, right? And you're saying, okay, what do I need to find now? I need to find the sine of 2 theta. How do I do that? You come back up here and you say, here it is. It's 2 sine theta cosine theta. So right here, I'm going to put this is 2 sine theta cosine theta, which is 2. Okay. Sine of theta should be 2 square root of 5 over 5. And cosine theta, we already knew from the beginning, but I mean, we could do it by looking at a picture, but we also know it's the negative square root of 5 over 5. Okay. And I'm sorry, go ahead. Okay, so look, what's 2 times 2? Square root of 5 times another square root of 5 would be 5. But what do we have though? We still have a negative. So I'm just going to put it right here. Negative 4 times 5 over 5, or over 25, I'm sorry. Because 5 and 5 is 25. And that's going to give me a negative 20 over 25, which I can divide both by 5. Negative 4/5. And we're done. Okay, so look, guys, we did part A, right? We got part A done. So let me scratch a line through that. This was part A. Let's do part B. Part B says, what is the cosine of 2 theta? Again, how do I do this? So scroll back over here. Here's my formulas. For cosine of 2 theta, y'all, we got 3 different formulas. Which one do we use? You get to pick and choose, right? I'm going to stick with this one here, that cosine squared minus sine squared. That's this one I'm going to pick. But I mean, which one do you want to use? You got a lot of options, or at least a couple. Okay. All right. So let's go ahead and keep doing this. Cosine squared theta. So remember, the cosine is the adjacent over the hypotenuse. So this is going to be a negative square root of 5 over 5 squared minus the sine, which was 2 square roots of 5 over 5 squared. Okay. So I'm going to give you all a hint. The number on the bottom is going to be 25. Anybody know what I'm going to get on top from this piece right here? Is it going to be negative 5?
No,
Positive 5, right? So remember we said negative and negative, positive square roots cancel each other out. Okay, let me ask you a question. And we're going to go slow here, guys. each of those pieces are going to be squared, right? So 2 squared is 4. 5 squared is, or square root of 5 squared is 5. So this is really going to give me 20, right? But we kind of knew that because isn't that how we got there to begin with, right? Okay, now we're almost done. I'll give you a hint. Bottom number is still 25. Positive or negative? Negative. Can we reduce that by 5? So what do we end up with? With a negative? Okay. Don't forget your negative and you're done. Let me ask you a question. How is 5.3 seeming so far? Way better than 5.1 and 5.2? Yeah? You hate 5.2? That's the, I'm sorry? What was 5.2? The sum and difference, right? Sum and difference ones, right? All right, so guys, we're almost done. We got one more part. We got part C. Look what part C is asking us to do. It's telling me tangent of 2 theta, okay? So the first thing I'm gonna do, y'all, I'm gonna come back up here. Here is my formula for the tangent of 2 theta. It is 2 tangent theta over 1 minus tangent squared. Okay. So let's see. The tangent of 2 theta is 2 tangent theta over 1 minus, what was it? Tangent squared? Okay. So let's look at our formula. Let's look at our picture and see what we got here. 2 tangent theta. So remember what we said tangent was? Tangent was opposite over adjacent, right? So look, I'm going to write 2 because there's a 2 right here, so I don't want to forget that. 2 square root of 5 over the negative square root of 5, right? Okay. Over 1 minus tangent squared theta, again, is going to be 2 square root of 5 over the negative square root of 5, but now it's going to be squared. Okay. So we're going to go slow. I'm going to copy this down here, guys, where I have a little bit more room because I am running out of room here. So it was 2 square root of 5 over the negative square root of 5 over 1 minus 2 square root of 5 over the negative square root of 5, but this piece was being squared, right? Okay. So first off, do you agree that this piece and this piece will cancel? Okay. So this is 2 times 2, which is 4, but that's going to make it in 2a. Okay, so we've got a negative 4 right here. All right, guys, just like we did a little while ago, this square root and that square root are going to cancel. 2 squared is 4. And if it was negative, does it make any difference or no? No, right? Because you can think about this as this piece is going to be a negative 2, right? So negative 2, when I still square it, is still 4. So 1 minus 4 on the bottom. Okay. Are we still okay? Negative 4 on top. What's 1 minus 4? Positive, negative. And negative 4 over negative 3 is just a positive 4/3, right? Because negative over negative is positive. And you're done. All right. So guys, the one thing I really want to, yes, sir, go ahead. So you're talking about there's a negative in front of the square root? Inside the square root, that's when you start dealing with imaginary numbers, right? So that was last semester college algebra. When you got the square root of a negative, that's when you start dealing with imaginary numbers, right? So if you have, I'm going to make this up. Simple problem. What's the square root of negative 4? Well, you already know the square root of 4 is 2. If you got a negative, I. I is the same thing as the square root of negative 1. Yeah, so you don't have to worry about it right now. We'll probably touch on imaginary numbers again, but a little bit bus later. Not right now, but we'll probably talk a little bit about them again. Okay. Huh? Oh yeah, yeah, of course. Okay, so guys, let's take a look here. Look what they're asking me to do here. They're asking me to verify an identity. Okay, so let's see if we can verify an identity. Let's see if we can do this in pieces. Okay, so guys, how would I approach this? I would approach this like I'm doing any other problem. The first thing I would ask myself is, do I have a formula for the sine of 2 theta? Yeah, we do. Anybody know what it is? We've done it a couple of times already. Good. Okay. 1 minus. Now, I want to say that we probably have some formulas for the cosine of 2 theta as well. And we have like 3 different ones, right? And wasn't one of them, and I'm going to put it like this, cosine squared theta minus sine squared theta? Isn't that the one we're going to use? That's when we did the cosine 2 theta. I said that we got 3 formulas, but we use that one every single time. Okay. So I'm just going to kind of keep playing around here and see what we end up with. So, I'm sorry, go ahead. No difference at all. Same thing. Same thing. Brackets, parentheses, little squigglies, don't make any difference at all. Okay, so guys, remember, this is really a -1, so I'm going to distribute that. So that's going to become a negative cosine squared theta and a positive sine squared theta. Oops. Sine squared, not 2 sine theta. Sine squared theta. Okay. And I want to say that somewhere, and let me see if I can pull it up for us. Where are my fundamental trig identities? Right here. So guys, in this fundamental identity, this one right here, the sine squared x plus cosine squared equals 1, right? If I use that Pythagorean identity over here, so I'm just going to kind of do this on the side. As a little side note. So I know that sine squared theta plus cosine squared theta is equal to 1. And so if I were to take this cosine and move it over, that would tell me that sine squared theta is 1 minus cosine squared theta, right? And if I look at this, if I look at this piece right there, isn't that the same thing as sine squared? Okay. And is this going to give me anything? I don't know yet. I'm just playing around and seeing what I'm going to end up with. That's a sine squared theta plus another sine squared theta. So now this is a 2 sine theta cosine theta over, isn't that 2 sine squared theta? Right? Okay. Now, I'm going to see what's going to happen here. Y'all agree that the 2's will cancel? Okay. Won't this sign here cancel with one of those? So what are we still left with on the top? A cosine theta, good. On the bottom, we still have a sine theta. Anybody know what identity is cosine over sine? That is cotangent of theta. And isn't that what we had right there? Okay, so guys, when we were here the other day in class, Don, I want to say you mentioned something about like, man, this feels like when a magician shows you the trick and you're like, whoa, how did all that happen? I want you to notice what we did here. All we did was we started messing with the formulas that we knew we had, right? Like we knew we had a formula for the sine of 2 theta. We knew we had a formula for the cosine of 2 theta. All we were doing was just manipulating those formulas. And guys, one thing I want to mention, y'all, is when I see something like this, that part right there, my mind immediately takes me to using one of those Pythagorean identities, right? So like I said earlier, when I said, there's some trig identities that you really want to become familiar with, definitely the reciprocal, the quotient, and at least this first one right here. At least that first sine squared plus cosine is equal to 1. These over here, do you have to memorize them? You don't necessarily have to memorize them. Like I said, you don't really have to memorize any of the formulas because you're going to have access to them, right? But what you want to do is you don't want to have to be going back and like, oh, what is cosine over sine? Man, I have no idea. You should know that, hey, cosine over sine is the same thing as cotangent, or sine over cosine is the same thing as tangent. Those are going to be, identities that you're going to really be familiar with. Okay, so let's see. All right, so here's another one. It says the sine of 2a minus tangent of a is equal to tangent a cosine 2a. Okay, let's see if we can figure something out here. Is anything going to happen? Quién sabe. Hopefully it does. Well, so hold on. Let's do this part. Don't we have a formula for this? Right? It's the same thing we've been doing before. So this is going to be 2 sine a cosine a minus, let's see. You know what we can do? I want to say that when we were doing our trig identities, one of the things it said is try to see if you can write things in terms of sines and cosines, right? So is that what you're asking about, John? So John says, look, let's go ahead and convert that sine a, or that tangent a into a sine a over a cosine a, okay? And let's see if there's anything else we can do here. So if we wanted to get these two together, we would need to get a common denominator. Everybody agree that common denominator would be a cosine of a? Because if this one is a 1 and that's a cosine of a, it's got to be cosine of a, right? So I'm multiplying by cosine of a in both parts. So this is going to be 2 sine a. Guys, cosine a and another cosine a? Cosine squared a, right? Minus sine a. All of this is now over cosine a, right? Let's see. What else can we do here? We're trying to get to a tangent a and a cosine a. Okay. So let's see. Can we factor anything out of the top? Is there anything here? Yeah. Well, do they both have a cosine? They both have a what? So let's take out the sine a. So sine a, and this is going to be 2 cosine squared a minus 1 over cosine a. Now, guys, remember what it is we're trying to get to. We're trying to get to what we have on the what? On the right-hand side, right? What's the first thing you see on the right-hand side? A tangent of a, right? Now, let me ask you a question. Does that look like a tangent of a to you? Yes, it does to me too, right? So I'm going to go ahead and write that right here. Look, this is tangent of a times 2 cosine squared a minus 1. Okay. So I'm trying to keep in mind what I have and what I'm trying to get to, right? So if I look at this piece right here, I'm like, look, man, that is right there. And then I'd look at, say, this piece right here, and I said, I want this piece and that piece to be the same. Remember when we talked about the cosine of 2a, I said there's 3 different formulas. And the one we always used was we always used cosine squared a minus sine squared a. I said, but there's 3 of them, right? If I come back to my cosine of 2a formula, isn't there one of them that looks like that? Y'all see that right there, y'all? Cosine of 2 theta is 2 cosine squared theta minus 1. Isn't that the same thing that we had over here? What? Like a magic trick? Okay, so I know you're talking about, but so what I want to really, hold on. So I really want to emphasize, I understand exactly where you guys are coming from, guys. It seems easy when I'm doing it here, but when you get home, you're like, what do I do? Okay. I'm going to tell you right now, a big part of it, and I can't emphasize it enough, is really understanding some of these pieces here, okay? So guys, I want to show you something that I remember, and I'm just thinking about it right now, but let me see. When we're talking about the Pythagorean identity, or the Pythagorean theorem, isn't this the form that we normally use, right? Because we're trig, on the x-axis, right, y, and the y-axis, r stands for my hypotenuse or the radius, right? Okay, so this is my basic Pythagorean theorem, right? Okay, let me ask you a question. If we came through and we divided everything by r squared, right? Because we have an equation, you can divide by any, as long as it's not zero, right? What is x over r? In terms of my trig functions, is it sine, cosine, is it tangent, what is it? Cosine. So then this would be the cosine squared theta. What is y over r? This would be the sine squared theta. R squared over r squared is? There's your Pythagorean identity, right? Now, what am I doing? I'm just starting off with the basic plain Jane Pythagorean theorem, right? Okay, what did we divide by the first time? R squared, right? Okay, let's play this game again. We've only divided by r squared. Let's divide everything now by x squared. Okay, x squared over x squared is? What's y over x? I'm going to give you a hint again. I don't want you to guess. I want you to think about it for a second. Y over x. Y is the opposite over the adjacent. Say it again. And okay. Think about it this way. You know what x over r is, right? X over r is what happens when you flip it? Secant squared. Okay, do me a favor. On the screen, where the Pythagorean identities are, is there another one that says 1 plus tangent squared equals secant squared? Yeah. There it is, right? Guys, we're going to do this a third time. We've already divided by r squared. We've already divided by x squared. Which one we still got left on? Y squared, okay. Markers are kind of fading a little bit, so oops, y squared. Okay, so let's see. You already know that y over x is, so what is x over y? Okay. Y divided by y it is? Okay. You already know that y over r is sine. So what's r over y? Isn't there another Pythagorean identity that tells us that too? Okay. So I'm going to tell you a little story, and it's not just a story, it's true. When I was taking trig, and I want to say it was probably, guys, more when I was teaching trig, like the first or second semester I was teaching. This one here, I know this Pythagorean identity, just like I know my middle name is Omar, my first name is Fidel, my last name is Rodriguez, and I know like everything about myself. I know this formula, left, right, I just know it, right? Do I always remember this one? And do I always remember that one? No. But I always remember this one. So I said, you know what, if I know this formula, look how easy BC cover color was for us to get this one. And if I know that basic, again, the Pythagorean theorem, right? If I know that formula, look how easy BC cover color was for us to get this one. You see what I mean? So, do you absolutely have to memorize it? You don't. Can you get to the formula? Maybe it's easier for you to do this, right? But guys, knowing those things, like, you know how we did this? And I'm just going to put this up here as well. Sine of theta is y over r. Cosine of theta is x over r. tangent of theta is y over x. Those, like, this is the first thing I think of when I think of sine, cosine, and tangent. And then I say, well, okay, well, how do you think of cosecant? Just flip it. How do you think of secant? Just flip it. How do you think of cotangent? Just flip it, right? But I always know these, like these, when I think of sine, cosine, I think that this comes to my mind immediately, right? I don't necessarily think of this immediately, but once I know these, okay, I know these too. You know what I mean? And it just makes it easier for me to do it. So my point though is, you gotta know some of the basic stuff. You know this, then you're gonna know this too, right? Do you have to memorize this? No, memorize this, and then you'll get these, right? Memorize that formula, and then you'll get, so, just by doing one simple thing. And if you know this part, then you'll know this part, and then you'll say, look, what's x over y? Cotangent, so that's gonna be cotangent squared. What is r over y? Cosecant, so that's gonna be cosecant squared, right? Because you already know some of those basic things. I don't know if that was helpful or not, but that's how I did a lot of this stuff, or like learned a lot of the stuff, or at least felt comfortable remembering some of those concepts, right?
It reminds me of you ever watch like some video show. He said anytime a physics professor, they'll say something about math is beautiful. And I guess the guy finally understood when he did that. Is like how it always perfectly lines up.
Like I said, you don't have to memorize every single thing, but if you know some of the basic concepts, all the other ones are going to kind of fall through. Okay, so guys, I'll tell you what, let's go through the next couple of problems so we can finish up 5.3. Look what we got here. We got sine x minus cosine x. The whole thing here is being squared. So I'm going to show you a couple of things. First thing I'm going to show you is, remember when I pulled up this formula sheet? The perfect square trinomials, I gave you this a minus b squared is a squared minus 2ab plus b squared. You can apply this formula for our problem here, or if it's easier for you to do it this way. And I'm going to do this, guys, because Thomas mentioned this earlier today, and he said, you know what, when I was like in high school, when they taught me how to do this stuff, they said just write it out twice and do the FOIL method. So remember what the FOIL method stands for? Oh, anybody remember FOIL method? First, outer, inner, last, right? Okay, let's do the first. What's sine times sine? Sine squared x, okay. What's sine times a negative cosine? A negative sine x cosine x, okay. We did the outer terms. Let's do the inner terms. What's a negative cosine times a sine? A negative cosine sine. Guys, I'm going to write it like this. I'm going to write it with a sine coming first, because I want us to understand that whether it's sine and cosine or cosine and sine, they're being multiplied. It doesn't matter which one comes first. They really are like terms. Then let's do the last. What is a negative cosine times another negative cosine? Very good. Positive cosine squared x. Okay, so let me ask you a question here. Are those terms going to cancel? What do you think? No, because they're both what? They're both negative, right? If one was negative, one is positive, they cancel. Minus sine cosine and another minus sine cosine is a minus 2 sine x cosine x. Guys, I'm going to point something out here. Look what we got here. We have sine squared plus cosine squared. What is sine squared plus cosine squared? 1. And on this side, we still have that. Still got that 1 minus sine 2x, right? Okay. What I'm going to do here is I'm going to leave this one alone, and I'm just going to move this guy to the other side. Not to the other side of the equation, but I'm just going to rewrite them, flip the two terms. 1 minus 2 sine x cosine x. Is it 2 sine x cosine x, excuse me, the same thing as this? Haven't we been using that double angle formula where we said that the sine of 2 theta is 2 sine theta cosine theta, or the sine of 2a is 2 sine a cosine a? So this 2 sine x cosine x is the same thing as 1 minus sine 2x. And if you notice, that is exactly what we got on the right-hand side. Guys, one thing I really wanted to mention, remember when we're doing the identities? The idea is one side going to equal to the other? Yes, they are. That's why there's an equal sign in there. They're telling us they're equal. What we're looking at is, how do I get from one step to the next? So everything that I'm doing, I'm trying to show every single step. I'm not trying to say, oh, plus from here you get to there. How do you know plus it says it's equal? Because I know it is. Can you show me how you get there, right? The more steps that you show, the more likely you are to get the full credit. But if you go, oh, I just did it in my head, I can't see what's in your head, right? So you got to write out every single step, right? Every single step. And that's all I'm doing here. Okay, so let me go ahead and move along here. Now, we have something called half angle formulas. So we have a couple of half angle formulas here, and I'm just going to kind of put them in this box. Here are our half angle formulas. And it says the sine of alpha over 2 is plus or minus 1 minus the cosine of alpha over 2. We got all these different formulas here, right? And it tells us here, guys, that the sine is either going to be positive or negative, determined by what quadrant of the angle alpha over 2 is going to be in. Okay, so this problem here says use the half angle formula to find the exact value of the sine of 5 pi over 12. Again, if I was sitting where you're sitting, the first thing I would do is I would say, what is 5 pi over 12 in degrees? Yes, I'm going to use that table that we did as well. You're definitely right. So 5 times 15 should be 75 degrees, right? So I'm going to say, okay, look, when I'm doing this problem here, it says use the half angle formula to find the exact value of the sine of 75 degrees. Okay, now I want you all to think about this, because from using that if the directions are telling me use the half angle formula, right? So guys, I'm really using this piece right here. So if I was thinking about this as the sine of alpha over 2, what I really want to know is, what number do I have to divide by 2 to get to 75? Or what's 75 times 2? 150. This is saying the same thing as the sine of 150 over 2. Okay? So, guys, remember what Thomas says. Can't we use that chart that we came up with? Yes, we can. And don't we have what the sine of 150 is? The sine of 150 is what number? 1/2, right? So all I'm doing here, y'all, is I'm using that I'm going to use this little table and doing our problem, okay? So let's take a look here. What does the formula say? This formula says we got to do this piece. So I'm going to go plus or minus, and I'll figure out which one I'm going to use. 1 minus the cosine of 150 all over 2. Okay, so I actually need to use the cosine of my angle. So let's see, what is the cosine of what's the cosine of 150? Cosine of 150 was negative square root of 3 over 2. Okay, so let's do this. So guys, we're going to go super, super slow here. We're going to say this is 1 minus the negative square root of 3 over 2. All of this is over 2. And I know this looks a little messy, and you know what? Why it looks messy? Because it is. But look, first thing I'm going to do, minus and minus is plus. Okay, forget about this 2 down here. Think of that as 1 over 1. What's my common denominator between these two? 2, right? So look, I'm going to multiply this guy by 2, and we're going to multiply that guy by 2. So this is going to be 2 plus the square root of 3 all over 2 divided by 2. Remember how we divide fractions? We say we multiply by b. The reciprocal of 2, y'all, is 1/2. Plus or minus, and I'm going to get to that plus or minus business in a second. Okay. So far I have a big square root, and I'm going to put 2 plus the square root of 3 on the inside. What's the square root of 4 though? 2. So we're using this big square root to take the square root of the bottom part. Okay. Now we need to figure out, is this thing going to be plus or minus? So let's take a look here. Remember what it tells me here? It says the sign plus or minus is determined by the quadrant of the angle alpha over 2. So alpha over 2 is really the number 75. 75 degrees is in what quadrant? 1, 2, 3, or 4? Quadrant 1. Is the sign positive or negative in quadrant 1? Positive. So when we come back over here, we're just going to keep it positive, right? Now remember what the directions told me to do. It said find the exact value, right? So guys, if I were to have used my calculator and I would have said, let me turn this thing on. I don't even know what mode I'm in. I'm in radians. Okay, so look, let me get out of here. What was our angle? 7 pi over 2 or something like that, or 7 pi over 12? Well, okay, so for this problem here, because remember the original problem gave me radians, so I'm okay just going like this. Like, what is the sine of 5 pi over 12? And it's going to give me this kind of mess, right? And that's not an exact value. What's an exact value? That part right there that we have in the red box. The square root of 2 plus the square root of 3 over 2. That's the exact value. If you were to take your calculator and you were to punch this in your calculator, you'd get that same number. But again, they're looking for the exact value, right? Okay, and guys, again, the main reason why I'm converting mine from radians to degrees is we could have done it. We could have filled that in on the chart. But when we did our chart here, notice all these values were in what? They were in degrees, right? Could I put the little equivalent next to them in radians? I could. You could do that too. But again, to me, it's much easier. When I think of 75 degrees, I can say that's 150 divided by 2. And I can apply that real simple, right? Okay, so let's see. I think we got another one here. Look what it tells me. It says the sine of my angle, sine of alpha, is negative 7 over 25. Alpha is between 3 pi over 2 and 2 pi. And it says, then find the exact value of the tangent of alpha over 2. Okay, so let's see if we can do this. First thing I'm going to do, what quadrant is this right here? Anybody know? This is quadrant 4, right? Good. We're in quadrant 4. So look, guys, we're going to do this. We're going to draw our triangle. Here's my angle alpha. Remember, the sine is the opposite over the hypotenuse. This is a negative 7. That's a 25. We still got to find our value of x, right? So we're going to say, look, x squared plus negative 7 squared equals 25 squared. 7 squared, anybody? 49. Okay, I don't necessarily expect anybody to know what's 25 squared, but does anybody know what's 25 squared? 625. Look at that. So you guys already knew. 15 squared is 225, right? So 625. How do I get rid of my 49? Subtract it. Let's go ahead and do that. Okay, so what's 625 minus 49? 500 and something? Let's see. Get my calculator. 625 minus 49. 576. And then we got to take the square root of that business. So square root it. 24. about you guys, but I'm pretty happy that came out to a nice little number, 124. Okay, so now we know what our triangle looks like. We're going to find the exact value of tangent of alpha over 2. So here we go. Here's tangent of alpha over 2. So look, guys, we can use 3 different formulas. I don't know about you all, but the last 2 look like they're a little bit easier, right? So I'll use one of the last 2. Which one do y'all want to use? The second or the third? Y'all tell me. Third, okay. Sine of alpha over 1 plus cosine of alpha. Okay, so we're going to go like this. We're going to say sine of alpha over 1 plus cosine of alpha. Okay, let's do it. We already know that the sine of alpha is a negative 7 over 25. The cosine of alpha is, so this is 1 plus, isn't that 24 over 25? Because cosine is the adjacent over the hypotenuse. Okay. All right. I'm not going to mess with the top part right now because there's not much to do there. But in order to get these 2 folks together, what do we need to have? Yeah, we can think of this here, guys, as 25 over 25. So I'll give you a hint. Bottom number is 25. What's 25 plus 24? 49? Good, good. It's okay. So we're all good here. Okay, now remember what we said. We're dividing fractions. How do we divide fractions? We multiply by the reciprocal of the bottom one, right? So look, we're going to go negative 7 over 25 times 25 over 49. Okay. So what's going to cancel first off? 25s. Anything else going to reduce? 7 and 49, that's going to be a 7 down there. So on the top, we're going to have a negative 1. And on the bottom, we'll be left with a positive 7. So we got it there, right? Whoa. For number 6, we ended up with right here. The square root of 2 plus the square root of 3 all over 2. So that it's a big square root, right? And inside that square root, you have 2 plus the square root of 3. All that divided by 2.
Could you run the math back on the problem?
But the one, this one here,
More like writing
number 6. Yeah.
Basically everything is right.
Yes. Okay, so look, let's do it like this. So what we were ending up with was, I'm going to write it real slow. So we had 1, we wrote it as 1 over 1 plus the square root of 3 over 2, and then all of this was still being divided by 2, right? Okay, so John, in order for me to get these 2 fractions together, you agree we need a common denominator? And that's going to be 2, and that's going to be 2? Okay. So 1 times 2 is 2, plus the square root of 3. Again, my denominator here is 2, and everything is still being divided by 2, right? Okay. Now, didn't we say that when you have a fraction and you're dividing a fraction by a fraction, you got to multiply by the reciprocal? So look, this is 2 plus the square root of 3 all over 2. The reciprocal of 2, 1/2. Okay. So now this is going to be 2 plus the square root of 3 all over 4. Right? And then all I'm really doing here, y'all, is I am separating my square root. The square root of a fraction says take the square root of the top, divided by the square root of the bottom. I cannot take the square root of the top because I don't know what this piece is going to give me. But we do know that that's going to give us 2. Yeah. And now we're done. So guys, before we leave for the day, because those were the last problems we had to do today. Between now and say next Wednesday, right? Remember next Wednesday, all we're going to do is say, okay, what questions do you guys have out of the review? So a couple things you really want to do. You guys were telling me right now that 5.3 seems a lot better than 5.1 and 5.2. If I was sitting where you're sitting, my goal would be let me knock out 5.3 as soon as I can. I mean, if I do it today, that's great. Or do it by tomorrow, whatever it is. But knock it out of the way. Don't say, oh, it's easy, I'll do it later. If it's easy, do it now. Then start working on the review. Start pulling problems that start doing the ones that you know how to do. You can skip around, right? Doesn't matter what order you're going. One thing I'll ask y'all to do is between now and next Wednesday, if you say, hey, you know what, sir, this is the formula that we used in chapter 4, but it is not on the formula sheet. Tell me, and I'll update the formula sheet, and I'll send you a new copy of the formula sheet, right? So all these formulas, guys, most of them came from chapter 5, but I mean, a lot of this business here is definitely chapter 4 stuff as well. But if there's anything, any formula or any sort of ratio or concept that can be, that's in that kind of an equation that you feel is going to be beneficial to put on the formula sheet, tell me. I'll throw it on there. I'll update it. I'll send it out to you guys again. You know what I mean? So you guys can have that. So, anywho, that's it for us today, guys. Don't forget that homework for 5.1 is due by tonight, as well as that class assignment, the second one, the class assignment number 2. So I know some of you guys already turned it in. I did grade your class assignment 1, guys, and I sent it back to you. If you sent it to me through Blackboard, I either sent it back to you through Blackboard or I sent you a copy of it graded through Pronto. And if you turned it in by paper, I gave it back to you by paper. I think I still have somebody's here. Let's see. Jason here? Jason, I have your class assignment number 1. So you can pick it up before you leave. But again, guys, make sure you do turn in class assignment number 2 so I can get those graded and back to you. Guys, some of you are showing a lot of work, which is great. Some of you are not showing enough, which isn't great. The more work you show, the more likely you are to get the stuff right, okay? All righty, that's it for us today, guys. Y'all have a good afternoon.